Hey everybody, today we will do another video, and probably I will start a new section. If I have some time, probably I will add more videos into it. It's called instrumentation, which is part of a circuit section, but it's more real life situation. So it's called instrumentation. So what is an actual instrumentation? Instrumentation is a real life situation where in engineering we implement system, but after we implement this system, we have to put them together, right? So in order to create a system, you might need a couple different blocks, right? And then, so you need within that different block that you have to form a system, you have instruments, right? Different instruments, not the one that you play with music, no, not type those, not guitars, not stuff like that. So instrumentation means that you have a system, a combination of systems, right? So in this case, the example that we're doing is the following. So it says calculate the voltage across a resistor. Okay, so it says calculate the voltage across, right? Across 10 kilo ohm resistor measure by a 100 kilo ohm meter, 100 kilo ohm meter. Actually, it's a voltmeter. Volt meter. Voltmeter with, right? Actually, it's where like this by a volt meter with a internal resistance of 100 kilo ohms, right? So I will explain something. In the figure, it says in the figure below. So now let's so now notice that in this word, just words, right? It doesn't tell us, and that's why in any type of problem solving you need to pay attention. That this is nothing, it's telling me, it's telling me something but not everything that I need, right? So right here, you can see that I need some more information. So the information is the following. So the following is so we have a battery like this, and we have a power source like this, and then we have a resistor like this, and then we have and then we have another resistor like this, and then we have another resistor like this, and then we drop those to ground, and do like this, and then right here you can go up. Okay, so now right here I have something like this that is called, and I think it has a circle on it. Yep. So it has a circle on it like this. And inside the circle I had a V. And then this is the meter. This is the meter that they're talking about. That is 100 kilo ohm resistance on it. So the meter is in parallel with this, right? So and that's why I brought my my little tool, because I told you that this is like representing a real life scenario. So let's say, for example, I am in the field, right? And I am measuring something. And this is the voltmeter. Actually, this is a voltmeter and the current meter. I can actually measure current with this. If I have a load, okay, I have a load, and I want to calculate the current, I activate the current in this, put it on, and it will measure the current. But in this case, I will measure the voltage. So what exactly I'm doing is this. See, I am doing this. So I'm taking one lead, put it right here, and this guy is sitting right there, like that, right? If you want to see it just like that, it's going to be just like this, right? So this is the V, right? These are the two leads. So notice that this is in parallel with those. Very important. Very, very, very important, right? Now I have enough put the value, so I know what the value this and this is. I know this is this is a 10K kilo ohm resistor. I need to put the values over here and over here. So, okay. Okay, so right here, this is a 10 kilo ohms. And I know this is 100 kilo ohms, right? Because that's what the problem statement says. Right here, the diagram shows this is a 50. This is a 50 kilo ohms, and this is a 25 kilo ohms resistor, right? So all those are, now we have all the values. This guy is that one, right? This is this one, and this is the one that I'm measuring from. They want to know what is the voltage at that point, at those points. But in order to do that, I have to know the whole thing, unfortunately. And that's one of the things that the price that we paid, right? Being problem solvers, but yeah, okay. So first of all, I need to calculate the resistance in this in order that this is in parallel with this. Even though this is up here, but if I switch this, it's going to be in parallel with this. Because this is just a wire, it's just making a loop, right? So I need to calculate this resistance. Actually, wait a second. I got another resistance. So, good thing that I got it. So let me just, I got another resistor right here. So this one is a 20K. This one is a 20 kilo ohms. So now let me just make this a little bigger so I can have some room. So this is a 50. Okay, I have already. So now I'll just drop this. So, okay, so notice that, let me just make it. Right? So now this one right here, this is a 25, this is a 50 kilo ohms, and this right here is a 20 kilo ohm resistor, right? So 20 kilo ohm resistor. Now we have all of them. Okay, now, okay, so now this one is in parallel with this, and this is one of the problem solving techniques that we need to learn. First, we start with the more complicated stuff, and we're reducing the stuff down. It's the same thing as being, okay, so, and then a voltage source of 10 volts right here. Okay, voltage source of 10 volts. Okay, now we have a complete diagram. Okay, so now let's analyze, right? Let's analyze this one. So this is a 10 kilo ohm, 25 kilo ohm. Okay, so let's analyze this. Let's see what we have, right? That's the first step when you solving a problem. What do we have? I have a voltage source. I have what they're asking for, right? They want a voltage across this resistor, and they give me the value of the internal resistance of that device. Internal resistance of that device is 100 kilo ohms, right? And then on the top of that, so think about this. So you have a panel. In a panel, you have some certain voltage drop, and you want to measure just in that drop. But down the road, from that branch of circuit, you got like a computer, you have maybe a machine, you have a robot, you have a bunch of things down the line, but you don't care too much about. You care, but you want to measure in that, right? And of course, when you do it with the device, you don't have to do all this. But unfortunately, when you're doing problem solving in the school, you got to do all this, right? Unfortunately. So now we calculate this resistance because we want to know the voltage across this, right? Why? Because we need to know the impedance in order to see what is the voltage drop in that one. Okay. Why? Because the sum of the voltage going around the loop has to be equal to whatever voltage is coming over here. Enter the loop, right? Enter the loop, leaving the loop, and then coming into the loop to the battery, to the source. Okay. So let's get it started. So we have this in parallel with that. This in parallel with this. This 25 ohm resistor is in parallel with the 50 ohm resistor, and it's going to be probably in series with this. Okay, so let's get it done. So R, so let's call it RA. Let's call it this RA. Whatever we found, RA is equal to, or you can call R equivalent. Let's call it RA, whatever. So all you need to do is identify this, right? So RA is equal to, let's call this R1, R2, R3, R4, R5. All right. So just to have R5. Okay, so now R3 is in parallel with R4. So R3 times R4 over R3 plus R4, right? Okay, so now that is that step. So it's going to be RA is equal to RA is equal to 50 times 25 over 50 plus 25. So when we do that, we get that it's 16.7 ohms, right? And one thing to notice is when you doing this, if you're doing the right thing, the result of this has to be less than the least resistance, and that when you talk. The least resistance that I have is 25, so the result is 16.7, so that makes sense, right? That's everything when you're doing and working in any type of problem solving, you need to make sense of what you're doing. And if it's making sense, probably you're doing the right thing. Otherwise, probably you're messing it up. Okay. So now this is RA. Okay. So now let's calculate. Let's add RA. So now let's make another variable. R as R in series is equal to R2 plus RA, right? R in series is equal to R2 plus RA. So what is my R2 is 20 kilo ohms, and I have the combination of this. Matter of fact, you can actually redraw this, and put it like this. So you can actually do 10 volt like this, and then like this. Actually, probably is way too small. Right here. So you can actually do it like this. You can do it like this. So 10 volt. So you got 10 volt, a 10K right here, 10 kilo ohms, and you have your meter right here. And then now this one, the result of RS, you can put it right here. So that's what I'm trying to say. You can simplify this. So right here you can put, after you add these two, because they are in series, now they are in series, right? So you can add those two, and you can make this right here like a block like this. And you can make, so RS is equal to 20K, 20 kilo ohm plus 16.7 kilo ohms is equal to 36.7 kilo ohms. All right. So this right here is 36.7 kilo ohms. And you can see that this one right here is already it's a simpler diagram, right? Because we 10 volts right there. All right, so now you can see that this is a simpler diagram. You can actually understand better because it's not as complicated. Now what I need to do is the following. So I have the resistance, I have this, but now this is in parallel with that. See? Now this is in parallel with that. So with that being said, that means that I need to calculate this resistance in parallel, and then do a voltage divider. So, okay, so now I need to do RT. You can say RT. You can say that it's equal to R total, right? It's going to be equal to, well, if you think about it, the voltage going across that is technically whatever the resistor is, the voltage is going to be the same. So in this case, so you can say R parallel, right? R parallel with this one is going to be 100K times 10K. 10K over 100K plus 10K, right? Now when you do that, you will find out that that is equal to that is equal to that is equal to 9K, right? So 9 kilo ohm. It makes sense because my highest over here is 10, my lowest is 10, and then I get a 9. So that makes sense, right? So now that I have this resistance, now I can even simplify this to the following. I can say that this 10 volts, and then I have I have 9 kilo ohms, and I have 36.7 kilo ohms, 36.7 kilo ohms, and then right here, and you can see that this is, see that? Now, it's very simple, right? So now what I need to do? Simply take this, because the voltage across this is the same the voltage across this. That's the purpose of using the meter, right? If I use the meter, to test that, whatever voltage is going across the resistor is going through my meter. Across, not through, I'm sorry. Across. I was going to make the mistake again, like other people do. Oh, you know, I have a voltage going through. No. The voltage go across the device. The current go through the wire. Right? That's how we define those things. Okay, so let's get this done. Okay, so now this is my simple diagram right here. Now, so now that I have this, all I gotta do right now is the following. So voltage, you can say voltage at 10, okay, at 10 ohm, at 10K kilo ohms, right? It's going to be equal to, it's going to be equal to what? It's going to be equal to, is equal to 10K times what? Time the voltage giving in the source right here. So times 10 volts, right? Divided by what? Divided by the total resistance, which is going to be this plus this, right? So it's going to be going to be 9 plus 37 or 36.7. And when we do that, we get, so we get times 9 so times 9 and then divided by 36.7 plus 9 is 198. So VR B10K is equal to 1.98 volts. And that is the answer. That is the answer for that problem. So now you understand, right, how you can reduce the step that you can take it to solve a problem like this. First, analyze the problem. You notice that this one is in parallel with that one. The meter is in parallel with that resistor. This was in parallel with that, and with this resistor, the 25 kilo ohm was in parallel with the 50 kilo ohm. We did the find the parallel equivalent resistance, and we got a 16.7. Then the 16.7 was in series with the 10K. With the 20K. We add them together. We got a 26.7. Then we got a 36.7, right? And then we did the parallel on this. Once we did the parallel on this, we simplified the circuit to 9 kilo ohms. And why we got 9 kilo ohms? Well, when we did this was 100. This was 100K. This was 100K, right? 100K. And see how do I notice that's the right thing? Because this resisting is less than that 10K. So now we got two resistors in parallel. In series. In series, we have two resistors in series. Then we did the voltage divider to find the voltage, right? So now we took the 10K, right, which is the voltage that we want to find, right, across that, and we did that times the 10 volts, and then we did this and then divided by the sum of the resistances, right? And then we got 1.98 volts going across that resistance. And that's it for this video. Thank you for watching.